All right, let's talk about the invisible force that runs pretty much our entire digital lives. It's the engine behind almost every single app you use, and today we're gonna pull back the curtain and see how it works. I mean, just think about your phone for a second. You've got your social media feed, your online shopping cart, your bank account. It is a constant, unbelievable flood of information. So how on earth does it all stay organized, secure, and ready for you in an instant? It's not magic. The secret is they all speak the same language. All these different apps, all these different systems, they all use a common tongue to talk to their data. And the coolest part? It's not that secret. Once you learn just a few key phrases, you can start speaking it too. To really get this, I want you to picture a giant, perfectly organized digital library. Every single piece of data, your name, a photo, a bank transaction, is a book on a shelf. This massive library is our database, and the language we use to be the librarian, well, that's SQL. SQL stands for Structured Query Language, and honestly, it's the master key to this whole digital library. It's how we build the shelves, add the books, find the exact page we need, and even decide who gets a library card in the first place. So, first things first, a library is pretty useless if you don't have any shelves to put the books on, right? In the world of SQL, you have to build your structure before you can fill it up with all that juicy information. You wouldn't just throw history books and with sci-fi novels, would you? Of course not. It's the same idea here. We create something called a table for each specific kind of information. So you'd have one table for students, another for courses, and another for teachers. Each one is its own dedicated bookshelf. And this is what the instruction actually looks like. I know, it looks like code, but stick with me. This command, create table, is literally us telling the database, hey, build a new bookshelf and call it students. And the stuff inside the parentheses, ID, name, and age, that's us deciding what kind of info each book about a student will have. We call these columns. Okay, the bookshelf is built. Now we've got to manage the collection, right? With SQL, it's super straightforward. Insert lets us add a new student, a new book to our shelf. If a student's info changes, say they have a birthday, update lets us edit their book. And if a student leaves, well, delete takes that book right off the shelf. Add, change, remove. Simple as that. Now, listen up, because this is super important. There are two very powerful ways to clear things out. Using truncate is like taking a huge arm and sweeping every single book off a bookshelf into a bin. The shelf is still there, just empty. Drop table, on the other hand, that's like taking a sledgehammer to the entire bookshelf. It's not just empty, it is gone. Poof, forever. You gotta be really, really careful with that one. So, our library is built. The shelves are stocked with books. But the real power of a library isn't just storing books, is it? It's about finding the exact piece of information you need when you need it. And this, my friends, is where SQL becomes a superpower. If you remember one word from all of this, make it this one, select. Pretty much every single question you will ever ask your database is going to start with this word. It's your way of saying, hey database, pay attention. I need you to find something for me. It's the starting point for all discovery. So check this out. Here's a quick peek at our tiny students bookshelf. We've got 4 students, each with their own ID, a name, and an age. This is the simple little data set we're about to ask some questions about. Okay, let's ask our first question. Who are the adults here? Here's how we'd ask in SQL. We start with select, name, age. That's us saying, just show me these 2 pieces of information. Then from students, that tells it which bookshelf to look at. And here's the magic part. Where age greater than 18, that's our filter. It tells the database to only show us the students who match that condition.
Finding individual books is cool and all, but what if we want to see patterns? That's where group by comes in. It lets us take all our student books and sort them into piles based on something they have in common. We could, for example, make a pile for all the 17-year-olds, another for the 20-year-olds, and so on. This simple act of sorting is the first step towards some really powerful analysis.
And boom, this is what you get. After we group by age, we can then ask the database to just count how many students are in each pile. And instantly we get this nice summary. We've got 1 student who's 17, 2 who are 20, and 1 who's 22. Just like that, a boring list of names has become a useful insight. This is basically the foundation of how businesses spot trends in their data. Okay, grouping is powerful, but sometimes we need to zoom out and see the big picture. We don't want to look at individual books or even piles of books. We want to ask questions about the entire library, all at once.
For example, this simplest question of all, how many students do we have in total? We just ask the database to count them. It scans the whole student's bookshelf and comes back with one simple number, 4. What about the average age of all our students? No problem. With one command, AVG, the database does all the math for us in a fraction of a second. The answer? 19.75. And what if for some reason we wanted to add up all their ages? Again, one simple command, sum, gives us the answer, 79. Tools like Count, AVG, and Sum are awesome because they let us find the big picture story that's hiding in all that data. Okay, so we've covered building the shelves and we've covered finding the books. Now let's look at the tools of the head librarian, the commands that make sure the library runs smoothly, safely, and super efficiently for everyone. Imagine you're transferring money. You need to take money out of one account and put it into another. That's 2 steps. A transaction bundles those steps together. Commit saves them both at once, but only if they both succeed. If something goes wrong halfway through, rollback undoes the whole thing, like it never happened. It is the ultimate safety net, the ultimate undo button. You wouldn't want just anyone to be able to wander into the library's main office and start changing records, right? The grant command is like giving someone a library card, but maybe it only lets them into the kids section. Revoke takes that permission away. This is absolutely critical for keeping sensitive data safe and secure. Think about it. If you wanted to find a specific author in a huge library, you wouldn't start at the first aisle and read the spine of every single book, would you? No way. You'd go to the card catalog. That is exactly what an index is in SQL. When you create index on something like a student's name, the database builds a special, super fast lookup list. It makes finding things incredibly fast. And there you have it, from building the shelves with Create Table to asking powerful questions with Select. SQL isn't some complex secret code for geniuses. It's the language of curiosity.